Hello, welcome. In this short video, let us look at some examples illustrating how to use numerical methods to verify whether a system is time invariant or time varying. So in this video, we are going to look at numerical method or numerical means for testing whether a system is or time invariant or varying. So consider a system that has the following relation, that is y of t is equal to function of time t and the input x of t. So given this kind of system equation, and we can use the input x of t equal to u of t and basically perform the following test, that is for the output y1 of t defined as function of t comma x of t minus tau, and another output y2 of t equal to f of t minus tau comma x of t minus tau. Then if y1 of t is equal to y2 of t, then the system is time invariant. Otherwise, it is time varying. So let us look at example 1. Y of t is equal to x of t multiplied by cos of pi t. So the input x1 of t is defined as unit step function delayed by a value 1. Here we basically assume that the delay is equal to 1. That is the delay tau. The delay tau is assumed to be equal to 1. So the input x1 of t is given as the unit step function delayed by a value of 1, and then unit step signal delayed by a value of 1, and then y1 of t is the corresponding output when the input is delayed by the value 1. So y2 of t corresponds to the function f of t minus tau comma x of t minus tau, that is all the time variables are basically delayed. So for this signal, the corresponding outputs are, the plot in blue is the output for delayed input, that is only the input is delayed and not all the time variables in the system equation are delayed. So only input is delayed, that is the blue one, and the green one is the output y2 of t. In this case, y1 of t is not equal to y2 of t. Therefore, the system is time varying. Therefore, this is time varying. Now let us look at a second example. Y of t is equal to x of t multiplied by u of t minus u of t minus 2. So for this system, let us look at the corresponding output. So clearly y1 of t is equal to x1 of t multiplied by the difference of the unit step signals, and then y2 of t is the similar signal, but for the time t is delayed by 1 apart from the delay in the input. So let us look at the corresponding output. You can clearly see that both the outputs are actually the same, that is y1 of t is equal to y2 of t. Therefore, this system is time invariant. Now let us look at another example. Y of t equal to 0.5, that is half multiplied by x of t and x plus x of t minus 1. It is basically an average of x of t with x of t minus 1, that is its delayed version. So for this case, let us look at the Python code. So this is y1 of t, that is x1 of t plus a delayed version, and in this case y2 of t is also going to be the same thing, that is the same signal. Therefore, we should see the same result. So clearly both y1 of t and y2 of t are actually equal to the unit step signal. That means y1 of t is equal to y2 of t. Hence, this system is also time invariant. Thus, by using numerical means, we can look at both the signals y1 of t and y2 of t and verify whether a system is time invariant or not. Thanks for watching.